Assalamu alaikum, my dear students. Let's read this example. Transportation officials tell us that 90% of drivers wear seatbelt while driving. What is the probability of observing 511 or fewer drivers wearing seatbelt in a sample of 600? Let's think about it. Do we have a discrete variable? Do we have a continuous variable? What do we have here? I don't see any continuous variable. Weight, temperature, time, I don't see anything like that. So it looks like I have some people wearing seatbelt or not wearing seatbelt. It's either yes or no. It's true or false. It's success or fail. So it looks like a binomial to me. This is a binomial question. Okay. Where the success is wearing seatbelt and the probability of success is p.9. Also, we have selected a sample of 600. For each one of them, he can be wearing seatbelt or not, success or fail, so that's my number of stages n. If p is 0.9, so the fail probability q is 0.1. Okay, so now I have a binomial. How can I solve this probability of observing 511 or fewer? I need the probability of 511, 510, 509, 500, so many probabilities, and it's impossible for me to use a calculator for this. I need the probability from 0 to 511. Also, the calculator cannot calculate NCX that way, because n is 600 and x is 511. 600 C 511 is no way a calculator will do it. So it looks like it's impossible to solve this question with a calculator. I have to find another solution. Well, we have another solution. Since n is very large, we can approximate the discrete variable to be a continuous variable. So I will use normal approximation. I have to use normal approximation. We still have to do a test to make sure that we can use it. Most probably for this large value of n, the test will succeed. But just to be sure, there is a test here that's like a condition before using normal approximation. That is, np should be greater than or equal to 5. Also, nq is greater than or equal to 5. np is 600 times 0.9. That's going to be actually 540, way bigger than 5, so that's okay. And nq will be 600 times 0.1, so when you multiply that, it will be 60, which is also way bigger than 5, so that's okay. Now we can use normal approximation. Well, before we go to the normal distribution, we need to have the mean and the standard deviation of the binomial, because this is what we are going to use also in the normal. The characteristics of the curve has to be the same. You're only changing the continuity. We're moving from discrete to continuous. That's all. So the mu of the normal distribution should be coming from the binomial, which is np, which we did before already, 540. And the sigma, the standard deviation of the binomial, is the square root of npq. Don't forget, it's the square root, not just npq, which is equal to 0.73, sorry, it is 7.348. So it is 7.348. Now let's continue this problem and move on to the continuous solution. Now I got mu equal to np and sigma equal to square root of npq. Now I have a normal approximation where the new variable is becoming continuous with a mean 540. And remember, I needed 511 or less, so that will be around my x1. Okay, 500 or less. So 500 itself, remember, it's an area around the 500. I want this bar that has a width 1 around the 511. Okay, so I also need another bar here for the 510, and another bar here for the 509, and so on and so forth. So the cutoff value here must be the upper boundary of the 511. That would be my x1. So x1 here should be 511.5. Why is that? Because the 511 itself is a bar. It's an area. Each one value in the discrete becomes an area in the continuous. And this area is basically a bar that has the boundaries of the value from 511.5 to 510.5. So that would be my x1. Now this is what I calculate z1 for, which is 511.5 minus the mean, which is 540, divided by standard deviation, which is 7.348. That will be 511.5 minus 540. This is equal to a negative quantity. We divide this negative quantity by 7.348. That will give me minus 3.87. So that looks like a minus 3.87. Okay, let's write that down. Minus 3.7.878, something like that. What was it again? 878. Okay. So minus 3.87 should be rounded to 2 decimal places. Should be minus 3.88. When you look at this in the table, I don't see anything here that is minus 3.7. The maximum is minus 3.4. I don't have anything more than this. I mean smaller than this in value. So what I can do here is to look at this here. What does it say? For values less than minus 3.49, just use 0.0001. So the area here would be really very, very small as 0.0001. So that's what I have to use for the area. So that means the area should be area 1 should be equal to 0.0001. Very small area, which is almost 0. So the area to the left will be almost 0. If you go back to the question, the answer that we have, closest answer, is approximately 0. Not this one. 0.1 is too large. Approximately 0. Look at my answer. It's 0.0001.